Good day, everyone, and welcome to this Gradle webinar. I'm your host, Oliver White, and joining us today for Troubleshooting Gradle and Maven builds with Develocity is my good colleague, Stefan Wolf. Stefan is a principal software engineer at Gradle who has worked on the Gradle build tool team for the last 9 years, delivering Gradle's famous build cache, and more recently working on Develocity Build Scan, which we will see live in action today. We get started today with a question. How much time do you spend each day troubleshooting your builds and tests? Most likely you're dealing with dependency failures, infrastructure explosions, nonstop flaky tests, and Checkstyle turning into Gandalf. You shall not pass. That's my best Gandalf impression, and yes, it's not very good. But everything's okay as long as it works on your machine, right? Not really. It's clear that we need proper tools to identify and fix the root cause of failures as quickly and easily as possible. And that's why Stefan is with us today. He'll walk through troubleshooting local and CI builds with Gradle and Apache Maven. We'll start by showing you how to leverage our free build scan service at scans.gradle.com to provide an X-ray of your project, then look at some use cases of well-known open-source Gradle and Maven projects using Develocity and the proven benefits that they see using it, and finish up with a deeper dive into both the Gradle build tool and Quarkus, representing Maven, projects, and review troubleshooting and observability tactics there. Lastly, this webinar and all of our DPE events are made possible by the support of our hundreds of happy customers, including Guidewire, who saves almost 11 days per week on parallelized CI builds with Develocity Remote Build Cache, and they are looking to fill engineering positions all over the world. Go to guidewire.com to learn more. Okay, that's all from me. Now let's hand it over to Stefan. Stefan, thanks for joining us today.
Yeah, thanks for the good introduction. Welcome, everyone. So let's see here. We're talking about troubleshooting Gradle and Maven builds with Develocity, right? So in troubleshooting experience can be very different depending on how you're trying to do it. Are you trying to sift through a lot of logs on your CI server? You need to SSH into some AWS machine and figuring out what log to look at. Or do you have a great tool that does most of the stuff for you and presents the results in a nice and digestible way? Well, that's how the experience may differ, right? And it all depends on you, right? And we are here to help. Question is, who's we? First question to start it off. So this is about troubleshooting Gradle and Maven builds. So who of you are using Gradle or using Maven, just drop a line Gradle or Maven in the chat and we see what kind of audience we have today.
So far, it's all Gradle. Both. There's a both.
Happy to hear that, given that I've been on the build tool team for 9 years now, right? But we also like our Maven users.
We love them. They have some of the biggest problems we deal with.
Yes, you're right. Okay, all right. And as a follow-up question, so this is about troubleshooting Gradle and Maven builds with Develocity. So most folks know what Develocity is. That's good. So here's a shorter talk outline. So first we talk about what this Develocity Gradle build tool is all about. Then we give a short intro to build troubleshooting in general, and then we look deeper into what Develocity can do for you for Gradle and Maven builds. All right, so yeah, some of you are using Maven, right? And you're in the via webinar hosted by Gradle about a tool produced by Gradle. So why would you even care? And yes, the elephant in the room is people laugh at Apache Maven, and we do too, right? So we had this Valentine's Day post, Gradle and Maven, match made in heaven, maybe not. That's the subtitle I added here. We're also sponsoring the Apache Software Foundation and doing as by providing a Develocity instance for the Apache Software Foundation, so developers are happy. And yeah, developer has so popular Apache projects like Apache Beam, Groovy, Kafka, the Scene, Pulsar, and Solar. So 30 of the Apache Software Foundation projects already are onboarded on the Develocity Gradle sponsors, and they're doing 33,000 builds a week. Those amount to 470 days of total build time per week. And they already get benefits, so they save 145 days per week from using the build cache alone. So what is Gradle really, right? So what is Gradle? So we have Gradle, the company, and the mission of the company of Gradle is make developers' lives better, make developers more productive, increase developer productivity, right? And for those, Gradle started out with Gradle, the build tool, that what you most know of Gradle, right? And Gradle the build tool was built to make developers more productive, right? So it perfectly fits with the component vision. And later on, we also developed the Develocity project. That's a particular tool. It's a developer productivity platform, right? So making forks that not only the forks that use the Gradle build tool more productive, but developers that use any build tool more productive. And finally, we founded this movement about developer productivity engineering as a practice, again, with the goal to make developers more productive. So let's see, everybody probably knows Gradle build tool. That accelerates developer productivity, right? By being a fast build tool, easy to use, being able to build anything and automate everything. Then we have developer productivity engineering, a practice used by leading software organizations to improve developer productivity and happiness based on metrics and data that needs to come from somewhere, right? So it's not only a qualitative kind of practice, it's actually an engineering practice, right? And finally, we have Develocity, the developer productivity platform that was formerly known as Gradle Enterprise. That allows you to have faster and more reliable builds and tests, right? 4 different build tools, right? We have Gradle, SPT, Bazel, and Maven. And recently we added better support for NPM and Python builds. Develocity as a developer productivity platform adds 3 main benefits to you, right? One is making your builds and tests faster, so acceleration features, being the build cache, predictive test selection, and test distribution. Then faster remediation. Here we are talking about developer and build engineer troubleshooting, right? So there are tools like the build scan itself and build scan comparison, test and build failure analytics, and flaky test management. And finally, if you want to know what's going on in all of your organization, we have observability and traceability features regarding performance and root cause analysis. And like I said, so not only Gradle is supported, we have Gradle, Maven, SPT, and Bazel support, and we have beta support for NPM and Python. And so it works, right? So we have many happy customers. And for example, we gave one of the top 3 global investment banks 2 hours per developer per day time back by cutting Maven build and test times by over 60%. And we don't only sponsor the Apache Software Foundation by providing a Develocity instance for them, we also support many other open source projects. Yeah, here's a Hibernate, JUnit, Spring, XVKey, and Quarkus, and all those things. And you can look it up. So if you want to experience a Develocity instance after this talk, just go to this Gradle Develocity open source projects and look them up, see what it feels like, and try to get an idea what Develocity can do for you. All right, now to troubleshooting builds. So what does troubleshooting builds mean, or what does it look like? So it all starts right when something goes wrong, and then you need to figure out what's going on. If you're just depending on the tools you use, it might be looking like that, right? And just floating around without much idea what is going on, where is all this coming from, why is everything broken, when did it start being broken in the first place? So in order to troubleshoot anything, you need to understand the cause of a problem, because if you can't understand the cause, then you won't be able to solve it. So for troubleshooting, I mean, that shouldn't be really news to you, right? We need to discover what the issue is, analyze it, and find the cause for it. Then applying the fix. That's surprisingly most often the simplest problem, right? If you know the cause of the problem, then applying the fix for it is very simple. And finally, and that is something that might be forgotten in quite sometimes, that you need to verify that the issue is gone and doesn't come back. And observability goes a long way in solving 3 of the harder parts of this troubleshooting problem. All right, so what can Gradle do for you with respect to observability to make your troubleshooting better? And this is, on the one hand side, we're talking Gradle the build tool. So what does Gradle the build tool do to make your troubleshooting better? And Gradle already includes many troubleshooting capabilities. So we're currently working on improving reporting and spec traces in particular. And one new thing that we're doing is the problems API and reporting problems. So one thing, so the problems API is a way for plugin developers and Gradle itself to provide structured problems to software developers and build engineers when running Gradle builds. And those will surface in the IDE and on the command line and give you a better idea what you need to look for and what you need to do. They will provide solutions. They will tell you exactly, this is actually something you as a software developer should fix, or this is something you should call your favorite build engineer to help you figure out the problem. So this is something that is introduced recently, the problems HTML reporting, Gradle 8.11. We are about to release Gradle. We already released 8.13, I think, and we are continuing improving the experience with the problems API and problem reporting. If you want to look into the performance and try to figure out why your build got slower or how it got slower, then Gradle Profiler is the solution you're looking for. And surprisingly, Gradle Profiler, even it tells you here that it's only about profiling and benchmarking Gradle builds, it also can be used for benchmarking Maven builds. And we actually use it ourselves to ensure that Gradle is faster as Maven. All right, but that's not enough. So only having the console log of one build or some information in the ID for one build doesn't help you to figure out the root cause, especially if it happens on CI. So how can we get more observability? How can we go deeper? And even as we saw before, we had the three pillars or three benefits of Develocity. At the bottom of it, observability is the foundation of all of it, right? Without having observability, you can't accelerate your builds because you have no idea what's slow and what you need to work on. And you can't troubleshoot your build because you cannot figure out the root causes of things. And like I said before, the main vehicle to provide you with observability for builds provided by Develocity is build scan. A build scan is a scan of your build that's produced whenever you run a build, being it locally or on CI, and that will be published to your central Develocity instance that runs within your enterprise. Or you can also, like Oliver said before, send build scans to scans.gradle.com to our free build scan service and provide the insight. But this really gets much more beneficial as soon as we have the Develocity available and be able to look at many scans and try to find correlations between those. So this is especially for troubleshooting. Then we have Develocity also provides local and remote build caching. It provides the service, but it also provides tools via the observability to make local and remote build caching more effective. We later look at flaky test detection and handling, right? How we can do that with Develocity. And finally, you also get observability of local builds, something that's missing from your normal workflow. So normally when you run CI builds, you get the nice receipt that you can send links around, but for local builds, it doesn't happen. All right, so let's start with flaky tests. And for that, I would like to ask a question again. So I wonder how many of you have to deal with flaky tests, and just write flaky in the chat if you have the problem. And if you don't know if you have to deal with flaky tests, can write non-flaky in the chat. But I currently believe if you're doing testing, then you will have to deal with flaky tests, right? Any other kind of test? Exactly. That's what we're talking about. Yes, exactly. So that's the right comment, right? If you don't have your flaky test, then you have flaky tests. All right. So I test the flaky. So what you're gonna do? You have few options, right? You can try to run it again, especially if it's on CI, and say, yeah, that change doesn't affect it. That really is not related to my change. Let's just run it again. It's fine. And maybe a few times more, just in case. And yeah, I'm pretty sure this is only flaky. Let's just ignore it, open an issue, somebody else needs to deal with it, or all of the above, right? And is that a healthy place to be? I'd say no, right? So there's this probably quote wrongly attributed to Einstein that insanity is doing the same thing over and over again and expecting different results. And that's what we're doing all the time, every day. So let's try to get out of insanity and do something useful. And in my experience, so what worked for flaky test handling is that you really need to separate the detection of flaky tests from the need to fix the flaky tests. So that means how can we detect flaky tests? So there's by using test retries, so the Maven Surefire plugin and the Gradle Java plugin supports test retry, so you can just rerun a failing test a few times, and if it passes, it fails one of the times and it passes another time, then it's flaky, right? And there's also a feature now in Develocity that allows you to detect flaky tests between builds. So if you have one build where a test failed and another build where the test had the same inputs and it passes, then you would call this test cross-build flaky because it didn't change anything and the test changed from passing to failing. But that's how detection works. So you change your build a little bit, and the important part is that the flaky test doesn't fail the build afterwards. So you even you don't have to deal with the flaky test when you want to merge your PR or when you want to get changes to CI. And at some point in time, right, either you do have a weekly check that has to be a new flaky test, or maybe you check on your branch, do I have some very flaky tests on my branch that I want to fix? Or you just say, when every 3 months we take a look at the most flaky tests and try to fix them. And then you do a conscious effort to fix the flaky tests, pull in the right people, and make the ones that are the most painful, be it because they became so flaky they actually do fail the build now, because even trying them 3 times is not enough. Or or they actually take a lot of time because retrying is not free, right? So if you have to run a test 3 times on average to make it pass, then it will take much longer than doing it only once. So, but the main point is separate the detection from having to fix the flaky test. All right, so let's see if this works. So what does it look like in Develocity? So I did prepare something here also. So this is the Apache instance, and these are all the builds that are sent to the Apache instance, and I sorted all the flaky tests that we have here in our test page by the most flaky ones, right? So we here see some Kafka tests. For this talk, I found this Hadoop test lease recovery test that seems to be flaky every time, right? But it has 100% flakiness rate, and it affects 160 builds in the last 28 days. So that's not great. And with Develocity, right, you separated fixing the flaky test from, separate detecting the flaky test from fixing it. So this is a time when we actually try to fix the flaky test. In this one, it's also a high time to fix it because you see there are already some occurrences when the test actually failed the build. But so let's look at this one. And so you can navigate to all the tests in the test class. And then you see it's not so clear, right? We see that all executions of the test class are flaky, but it's not always the same test, right? In 58% of the cases, it's one of the first 2 tests. And in the other 2 cases, it's the third test. But all in all, one of these 3 tests will always fail. So now we need to figure out what might happen there. There you would look at the test history of one of those tests individually. And at least each individual test fails with the same message every time, right? Doesn't also seem to matter on which branch you are. And it's somewhat proportional to the number of test runs, right? And then we can dig deeper, right? We need to go deeper, like we said at the beginning, and dive into an individual build scan where we see the test execution, right? The first failed one and the second successful one. And here, because we know that the whole test class is flaky, it makes sense to look at in what order the tests ran and what log output we have here, right? So this is the log output of the whole test class. So this is one execution. And here we see that this get committed block length with exceptions, or the other flaky test passed, and then both of them failed. Right? And we can also look at the other version, right? So this is one of the versions when the other test failed. And you see, yeah, this one failed and the other 2 passed. So it seems like there seems to be some interaction, and also when they fail, so if you go back here, when they fail, they are really fast, right? So it's a few hundred milliseconds as opposed to a few seconds. So I suppose there's some race condition or something doesn't start up correctly, and then those fail, and after those are done, right? Or maybe even this test destroys some of the state, right? And then makes those 2 tests fail. So this would be something for the Hadoop maintainers to look into and figure out what is going on there. They will definitely have more context than I have from looking at this test a little bit. So, but you see, this is how you can drill into a single test or a flaky test and really go deep. And you could also ask yourself, all right, so this test failed. This happened at 14:15. So what happened at this time in the build? And recently we introduced the resource usage capturing on the timeline. So we need to go to the 14:55, 15 time, that's around here, right? And then we can go deeper and figure out what happened around this time, right? And we see from this point, we can't really make much sense. So it's probably not a resource problem. But for other tests, it might be that you run two test goals in parallel, and those two might be interfering with each other, or one of them takes too much memory. All right. So, and that allows you really to dig into your flaky tests and be able to fix them. And afterwards, you can also, when you look at the dashboard again after you fixed it, you can also see that the flaky test went away. Maybe take a quick look if you can see, especially for example, if you look at this abstract coordinate test, that looks really good, right? It looks like somebody fixed this like half a month ago. And same for these tests, right? So these really got better, and maybe we find another kind of pattern that something got worse. But it seems like everybody's happily using Develocity and doesn't run into any problems now. And now for some reason this slide just stopped. All right, so much for flaky tests. So this is really about developer troubleshooting and figuring out why your tests are flaky and how to fix them. And the next topic is more CI troubleshooting, or so what is going on in my CI instance. And the example I chose there was underutilized CPU resources. So what does that mean? Develocity comes with a feature called DRV, Develocity Reporting and Visualization, that provides various dashboards based on the data captured by Gradle build scans. And one of the data is the resource usage graph you just saw, and we can actually see the differences. You can see how much CPU resources are used during execution time of your build. This is the instance for the Gradle team itself, or the Gradle build tool. And we add, apart from the Gradle the build tool that amounts to most of the build scans that are in that instance, we have quite a few other ones, other projects. Now let's stick, in this graph here on top basically means if I would use 100% of CPU resources, how much faster would my build be? Under the assumption that everything could run in parallel. This means like 1/3 of the CPU resources unused. On CI, that's not too bad, right? We could say, yeah, let's just cut a few CPUs from our CI instances, but let's look at another problem right now. So here we have a breakdown of the tasks that ran and the unused CPU time sorted by the unused CPU time. And here we in particular see that this clean smoke test kind of task has a lot of underutilized CPU resources. So the execution time is on average 15 minutes, and it would only take 6 minutes if it would run fully parallel. And now you can try to figure out what is going on. Right? And first you would search in your Develocity instance, in this case g.gradle.org. You would search for the tests I just showed, and you get a few, right? And then you pick an arbitrary one and look deeper into it. And if you look at that build, right, I zoomed in a little bit. Oh, maybe I should zoom out again. So you see at the beginning there's some higher CPU usage and some a little bit different kind of memory pattern, if you want to. But then at some point it falls into this usual memory pattern that the memory increases and then garbage collection kicks in. And so on, right? And the CPU usage is around 30% for most of the build. And this is running a test task. So what is going on here, right? So why is it not using all of the CPU? And we can run tests in parallel. There's nothing stopping us from it. And looking at this pattern, you can actually look at the test page, because it's a test task. So let's see what tests we're running. And here we see again that nearly all the time is spent on this one test class. So this test class runs for 37 minutes. And all of the parallelization we do, whether it's test distribution from Develocity or Gradle parallel executing, it's all based on the test class. So what happens is, okay, right, we run 4 because the split for this test task is 4, right? We run 4 test tasks in parallel, and yes, we start maybe with that one and 2 or 3 of those. But then at some point, all the other test classes are done, and we end up running this one for probably half an hour or something like that. And then it's just, there's no parallelism going on. And this is something we could fix, and we probably should, but if we fix it, I can't use it for talks anymore. So I'm trying, yeah. So this has been communicated that we should fix it. So by splitting this test class, this is a huge work loss, and we can split the test class into smaller pieces, and then those would run in parallel, and we could cut down the time this build runs. Or if we just yeah, actually I don't care. I have the time. Do we have the hour? Probably not. I can just say, yeah, let's just give this whole build fewer CPUs, and then at least I don't pay for this much on CI. So this is another example how we can dig deep and either save CPU resources or make your builds faster, right? Get faster feedback time by looking at the data you captured by Develocity. And the resource use data is also available on the free build scan, but there's it's only for individual builds. All right, finally, I talk about how to make the build faster by using observability data, in particular how to make the build faster by using build caching more effectively. And to clarify, so the Gradle build cache is available for Gradle and Maven, and I think for SPT as well. For Gradle, you can also provide your own backend and go with it. And you have a remote build cache for Gradle. For Maven and SPT, you need to use Develocity and get a license to use the remote build cache. I think the local build cache for Mavens, as well as the Develocity one, and there's some other kind of build cache that's not exactly what I'm putting in for Maven as well. But let's look at what the build cache means, right? So regularly when you run a build, you do some work, and whether it's a Gradle task or a Maven goal, it will have some inputs, be it your source files and some Java dependencies. It will do something with the inputs, so compile them, for example, and then you get some outputs. And that is what this work unit is doing, right? And the build cache, what it does, yeah, and then you start again, right? You always start again and make some changes and run the build again. And what the build cache does, it captures the inputs in some form, and if somebody ran this task or goal on some other machine already, so mostly from CI, right, you would get the results from CI. Or if you ran it locally, you would go back to the state again. So it's a way to make builds really faster, whether you fan out CI builds and would run compilation in all of your fan out builds, you would just pull all the compiled things from the cache. Or if you run local builds and you pull changes from remote, you get the remote task or goal outputs from the cache and get a faster build and don't need to run that stuff locally. And how can Develocity help you there? And the answer is again build scans. So what's often very hard is to get cache hits, right? Because you make a change or you don't make a change, right? You run something on CI, you run something locally, and you would expect to get the result from CI, but you don't get it and you have no idea why. And then this feature comes in from Develocity that allows you to compare two builds. And here I'm comparing 2 Maven builds, right? And you can see each of the differences in the cacheable goals, in all goals that you're gonna run, right? You have here a compile goal, and you see, yeah, this char dependency changed, so that's the reason why it ran. Or you can see here somebody changed the flag, right? So that is why I don't get a cache hit. And you can for source directories, you can even see that down to the individual source file, like here, that one, like here, for example, right? You see, okay, between these two builds, somebody actually changed the Let's Encrypt helpers file, right? And that is why I don't get a cache hit. And without that, it's very, very hard to make your caching work well. And I would even say it's impossible, whether you use Gradle or Maven. But with this tool, being able to make remote caching work and actually drill down into problems, having the data, compare to builds, and figure out what caused the cache miss, allows you to make your caching work effectively and give you the benefits you expect from your local and remote cache, and make your builds faster and developers more productive. All right, we're coming to an end now. Maybe I can give some outlook on what's coming to help you with developer troubleshooting in particular. So Develocity 2025.1 is around the corner, and that will have the first help that build scans get better for developers. So it will show you right on the summary page when your build failed, what made the build fail. So if it's test failed, it will show you already the tests that failed, and if it's a task failure, it will show you the tasks that failed. And even better, we have a better feature that allows you to also cluster similar tests together by using a little bit of AI and help you figure out what are similar goals in a single build scan. And we will be working more deeper on developer troubleshooting, and there's also a webinar coming up from my colleague Laurent in a month, I think, about developer troubleshooting using artificial intelligence, I think. Right, so back to the reference.
We like that you've enjoyed seeing what Develocity can do, and we want to invite you to a guided trial. Some of you in the audience are already doing one with us, I see, which is great. The way it works is you work hand in hand with our engineers to prove time savings with our acceleration technologies and reveal bottlenecks, flaky tests, and other opportunities for being more productive, troubleshooting faster, observing everything that goes on in your entire build tool chain. And at the end, everything is summarized in a nice report that shares an ROI and all the time savings you can have, so you can give it to your boss to make that decision a no-brainer. You can check that out at gradle.com/trial, and you can tell them Oliver sent you. All right, that goes for any of you in the audience today. If you're looking to meet someone at Gradle and start talking about Develocity or free build scan, any of those things, you can feel free to email me, and I'll do my best to get answers for you. So if that's all for today, I'd like to say thank you very much to Stefan. Very good presentation. I think we all learned a lot. I always learn something when I sit down with you, Stefan, so it was good for me too. And I hope everybody has a wonderful day, and thanks for joining us. Thanks. Bye-bye.
Thank you, Oliver, and thanks for attending.